Hello everyone and welcome to the 9th electronics tutorial. In this tutorial we will look at how to calculate power on a DC circuit. Power is measured in watts, and as we will see in this tutorial, the calculation for power is an extension of Ohm's law, which we covered in tutorial 1. We will also use the volts, amps and ohm meter in EC to help us find the values we need to make these calculations. With these built-in tools, we can easily find the total for volts, amps and ohms which we need to calculate the power. Components have a maximum power rating, and it is important that we find the power output to ensure we do not exceed the maximum limits. Let's firstly look at the voltmeter to check the voltage over a resistor. Here we have a simple circuit with a 5 volt power supply. It has a 100 ohm resistor and a 1.5 volt 30 milliwatt lamp. Let's use the voltmeter to read the voltage across the resistor. We click the voltmeter icon and place it above the resistor. Then simply click either end of the voltmeter to connect it to either side of the resistor. When we play the simulation, the voltmeter reads that there is 2.86 volts running over the resistor. Let's use the ampermeter to check the current flowing on the circuit before and after the resistor. To do this, we will click the ampermeter icon twice, so we can place 2 of them into the workspace. As with a real-life ampermeter, we need to place it in line with the components so we can make the reading. With 2 ampermeters in place, we play the simulation to see the results. As we can see, there is 28.6 milliamps of current flowing before and after the resistor. Let's now try the ohmmeter. To demonstrate the ohmmeter, we will use this circuit, which has several different values of resistors in series and parallel. To calculate the total resistance manually on this circuit would take a little time. We can simply use the ohmmeter to do this for us. Instead of placing a power supply on the circuit, we place the ohmmeter. The ohmmeter adds a small voltage to the circuit to make the reading. Starting the simulation shows us the total resistance of 98.2 ohms on this circuit. So as we have demonstrated, these tools are very useful and will aid in checking if a circuit is running at the expected level. Here we have 3 amplifier circuits. Each circuit has the same power supply, but the base resistors are at different ratings on each one. We can use the voltmeter to show the voltage over the 1 kilo ohm collector resistor and compare the outputs more easily. When current flows through a resistor, it dissipates power, usually in the form of heat. Power is measured in watts. Let's analyse this sample circuit and calculate the power dissipated. This circuit has a 9 volt power supply, a 500 ohm resistor and a lamp which has a power rating of 30 milliwatts. Let's replace the power supply with the ohmmeter in order to find the total resistance on the circuit. As we can see, the total resistance on the circuit is 575 ohms. We can now calculate power dissipated by using the following formula. Voltage squared divided by total resistance. Voltage equals 9 volts. Total resistance equals 575 ohms. 9 squared equals 81. 81 divided by 575 equals 0.14 watts or 140 milliwatts. We can also use the current to calculate the power by using the following formula. Total resistance multiplied by the current squared. Current equals 0.0157 amps. 0.0157 squared equals 0.0002469. 0.0002469 multiplied by 575 equals 0.14 watts or 140 milliwatts. And when we know the values of current and voltage, we use this formula. Current multiplied by voltage. Current equals 0.0157 amps. Voltage equals 9 volts. 0.0157 multiplied by 9 equals 0.14 watts or 140 milliwatts. We use the same formula when calculating the power dissipated over a single component. We need to ensure we select the correct power rating for the resistor. The resistor has 500 ohms. The voltage supplied is 9 volts. Using Ohm's law, we find the current, voltage divided by the resistance. 9 divided by 500 equals 0.018 amps or 18 milliamps. So using the power formulas, voltage squared divided by resistance, 81 divided by 500 gives us 0.162 watts or 162 milliwatts. Resistance multiplied by the current squared, 0.000324 multiplied by 500 gives us 162 milliwatts. Current multiplied by voltage, 0.018 multiplied by 9 gives us 162 milliwatts. At 162 milliwatts, we can use a quarter or 0.25 watt power rated resistor in this circuit. So as we have seen in the previous calculations, as resistance increases on the circuit, the power output will decrease. Where the power output is high on a component, it is possible to attach a heat sink in order to dissipate the heat more efficiently. I hope you've enjoyed this tutorial. In the next tutorial we will create a voltage and a current divider. Please feel free to ask questions and leave comments. Thank you for watching.